is a full course in trigonometry. We're not going to do a full course in trigonometry. How can we do that? Since we're already in week, what, 6? Yeah, I spelled that way wrong, didn't I? Trigonometry. That's been the day today. Trig-o-nom-it-tree. There we go. Trigonometry. Right triangle trig. We're not going to do a full course in trig. It's super interesting. It's probably my favorite math course to teach, but we will see like the highlights of trig. Predominantly, the trig you need to be successful in calculus. Let me just switch this up. So we're going to begin with a foundation in right triangles. So I'm assuming, just so you know, I'm assuming we had no trig background, but we have some background, right? We've all had some education. We know what a right triangle is. So you tell me, what is a right triangle? What's that? The edge of a whiteboard. Yeah, so it's got like a sharp, pointy corner. And it's a triangle because we passed second grade, so we know it's a three-sided shape. That sharp, pointy corner is called an angle, specifically a 90-degree angle. Sometimes we use this like half square symbol to show that it's a right angle. And that's what a right triangle is, the end. Hang on 1 second. All right, sorry about that. Okay, what do we call the three sides? Specifically, what do we call the side? All right, I'm going to use a word here. Opposite. That's a weird thing to say, opposite. All right, first of all, opposite is an important word. If I'm at this right angle, and I'm going to end up erasing this, so kind of just watch. But I have like here's my arms, but I have 1 foot and 1 foot on like these two sides. Kind of weird. I'm like, ugh. The side I'm looking at is what we call opposite, right? So where my feet are standing, I'm on one side, The side my feet are not on is my opposite side. What do we call the opposite side in what's opposite the right angle? The hypotenuse. If you've had no trig, this actually becomes an important thing to recognize. You have to recognize the hypotenuse. Cool. There are 2 other angles inside a triangle. Does anyone remember what has to be true about 3 angles in a triangle? They have to add up to 180. So if this is already 90, which it will be in every single right triangle, and both of these have to add up to 90, that means individually they're less than 90. Does that make sense? For instance, these have to add up to 90. This has to be 30 and 60, or 89 and they're less than 90. What do we call angles less than 90? Very cute. Halloween has passed or coming up. Valentine's Day has definitely passed. This is called an acute angle. This guy over here is also an acute angle. All right. Well, since there's 2 acute angles, we name them typically with capital letters. I'm going to call this one A. I will call this angle over here B. I don't know if it's 30 and 60 or 89 and 1. I'm just going to say it's unknown A, unknown B. Heck, I'll even call the 90 C and I'll come back to that. We now have acute angle A, acute angle B, right angle C, opposite right angle C is the hypotenuse. Here we go. From acute angle A, what segment, use two letters, is opposite A? Remember what I said about opposite? I'm a stick figure. I'm chilling here. So if my feet are standing here, that's the way I think about it mentally, what segment is opposite me? B to C or C to B. It doesn't matter as long as you kind of recognize this. Cool. Who is adjacent to me? Adjacent, if this is opposite acute angle A, and this has already been labeled hypotenuse, then by process of elimination, we call this last side adjacent to angle A. So here we go. I'm going to put all that now in writing. This side right here is opposite. Oops. Doesn't really matter what color I use, but I'm going to say opposite angle A. And this side right here, we name adjacent to angle A. Last thing before we really get going. These are the big three words in trigonometry coming up really soon, which we're tackling. Opposite, adjacent, and hypotenuse. So before I move on, we're always going to find our hypotenuse, which is always going to be opposite 90. And we talked about what opposite means now. There's two other angles. Very soon, someone has to tell me, am I at A or B? And if you don't see Y yet, it's coming, right? But I started by saying, all right, we're going to start at A. There's a consequence. If you tell me A, this becomes the opposite, and this side becomes the adjacent. Here's the outcome. If you said, Professor Matt, yes, go to angle B, there's a different consequence. The hypotenuse is going to stay the hypotenuse. But what side is now opposite? This. And the word's going to change. Okay. So the side that's adjacent to angle A is also the same side that's opposite angle B. Do you see where that's going a little bit? Okay, so the words opposite, adjacent, and hypotenuse play a big role, as well as what angle we're talking about. What's up?
So opposite and adjacent are relative to whatever angle?
The acute angle. Because always opposite the 90 angle is the hypotenuse. And vocab plays a role here. That's why I'm going cautiously, because once it's laid out, it makes sense. You cannot get it wrong. We haven't done any trig yet. That's just vocab. Speaking of right triangles, you ask the average person on the street, what one formula do you remember from math? Pythagorean theorem called a squared plus b squared equals c squared. Super common. I purposely use capital letters. I didn't just willy-nilly do that. I did that on purpose. Typically, capital letters are angles, and we use lowercase letters for sides. I'll write that in a minute. Since this is capital C, we call the side opposite lowercase c. Since this is capital A, we call this side lowercase a. And since this is capital B, we would call this lowercase b. Capital letter C, capital letter A, capital letter B. I am going to say typically. And when I say typically, I mean like a high percentage, but some professors, some YouTubers, some textbooks get a little sloppy, but I'm going to try not to be sloppy. Capital letters are angles. Most teachers, YouTubers, professors, textbooks will do this. And then lowercase letters are sides, opposite those angles. So one last time. If this is capital A, this is the opposite side. We call it lowercase a. Capital B represents some angle, maybe 60 degrees, 90 degrees. No, it can't be 90, 89 degrees. This is lowercase b. And this is capital C. That side is lowercase c. Cool. All right. So it's a little dry getting going. If you feel this is dry, or if you're like, no, I like this. I like vocab. But it's important that we label it that specific way. In a right triangle, if C is the hypotenuse, which it is, then the most famously known formula to people on the street is that A squared plus B squared equals lowercase c squared, known as the Pythagorean theorem. Theorem. Pretty awesome formula. Crazy amount of applications in math and sciences. It's crazy. It's just insane where it comes up in different places. But for us, it just looks like symbols on a screen. Everyone okay? All right, so triangles have three sides. We're looking at two of them right now. We have a right triangle, so we are allowed to use Pythagorean theorem. And I said something kind of quickly, but it's also important. It says, if C is the hypotenuse, so there's no letters here, I'm going to label the hypotenuse C. Now, A and B, we can be a little bit messy with, but you can't mess up C, because it is on one side of an equation. A and B are on the other side of the equation, and if you switch them up, addition doesn't care. But C has to be on that side. If C is the hypotenuse, now I put a C in there, then the Pythagorean theorem says 3 squared plus 4 squared equals C squared. And 3 squared we know is 9, or a calculator would tell us that. 4 squared is known as 16. Make sure you do exponents before you add the numbers. It's not 7 squared. That's 25. We take a square root of both sides to undo exponents of 2. And our missing side, the hypotenuse in this triangle, is 5. Yay! Yeah, fixing that up. Find the missing side. Here is a fake, bogus answer. So I don't know if you want to write it down. But I've stressed something now twice, and I'm going to really emphasize it right now. This is going to be fake. 12 squared plus 13 squared equals c squared. Wrong every time. Okay. If you were thinking that, then you can't think that. Wrong. The hypotenuse has to go in the place of c, and it's not unknown right now. The hypotenuse is 13. It has to be c. What we call a and b over here doesn't matter. So I'm going to go with A. Maybe next week or in 5 minutes, I might call it B. It doesn't matter. It's the other missing side. What does matter for the fourth or fifth time, 13 is C. So we have A squared plus 12 squared is 13 squared. I don't know. My calculator doesn't know how to do that. I don't know how to do that. Leave it alone. But 12 squared is 144. 13 squared is 169, which is on the other side of the equation. What are we going to do to solve for A? You're going to get the number 25. What do we do next? You're going to get the number 5. Okay. Brief review on Pythagorean theorem. I do see this. I don't want to see it. Especially if he took on a little bit of water. We're going to keep positive. We're going to spring break really, really soon. But we want to make sure we're coming back ready to go. Okay. Questions, comments, concerns? I lost my spot here. There we go. Nexties. I want to just lay out less than 5 minutes of the backbone of trig, not the full math answer. You're not math majors or going to be math teachers, but it's still worth to have. I could tell you the facts right now, and I'm going to less than 5 minutes, but I just want to at least give a little more than just because I told you so. And this is the theory of it. And you don't need to write this down. This is like watch for 3 minutes or so. I have this triangle. Do you know what tool we use to measure angles? Protractors. This is not a protractor. It's what comes in this app. But I can. It's a little more than 30. This is. I'm going to say 35 degrees. That's supposed to be a right angle. What would happen if I had the ability to bring this projector wicked close? It would shrink. It would shrink. Do you believe that? I definitely believe the size would change. So meaning right now I have this ruler. Okay. That's probably 3 rulers, 2.5 rulers. Let's say 24, 30 inches. That's 30 inches. That's literally, right? If you took them, go to job lot, come up to here and say, how tall is that? 30. But if you pull the projector right here, you'd be like, yo, it's 3 inches. Whatever happens to me. It's definitely smaller. So the sides change. Does the angle change? No, the angle's still going to be 35. And if you don't believe it, one, do it. I don't know how, don't do that. But I can convince myself this. Aren't we still definitely going to have a sharp corner angle? Yeah. So, okay, the angles are not going to change. What's that? We're getting there. Yes. Furthermore, if this was not rushed, not a 16-week course and actually built to be engaging, I would be passing out rulers and stuff right now. I'd be like, all right, let's do it. Let's actually zoom stuff out. And I'd say, whatever your distance is, go half that distance. Well, guess what would happen? That 30, if I said go half, would become 15. Interesting. That's freaking cool. It really would happen. Maybe not perfect because we know there's human error, but it'd be freaking close. So I'm going to do that in a new way. I'm going to pretend I zoomed in. This was 30. I'm saying go halfway, take a leap of faith or not, go do the experiment another day, then that would be 15. And if this original side over here was, I don't know, 40, I'm guessing. Oh, I actually want to slow this down a tiny bit. So say go half, this is 15. Now I'll say this part was 40, I'm just guessing. Again, this is, I'm in within my 5 minutes. Let me get to it. Do you know what that would be? Has to be 20. And those proportions that Mike brought up would be the same. What proportions am I talking about? The side opposite 35 was originally 30. Opposite. The side, it's not hypotenuse, the side adjacent was 40. That ratio, opposite over adjacent, is 30 over 40. It simplifies to 3/4. But if you scale geometrically, like we scale graphs, if you scale this object, if you shrink it or make it bigger, and still say opposite 35, because that didn't change, to adjacent 35 in this smaller triangle, you end up with the same ratio. If that clicked for you, that's what trigonometry is. Trigonometry, this part you might want to start. If you're, I'm really going to build from here. Trigonometry is the study of ratios in right triangles.
Only right triangles?
Nope. But it can, it's a good place to start.
Okay.
And we're going to break that after spring break. No pun intended, break after spring break. But it's a good starting point. I almost should put that in quotes because it's a lot, way more than that. But we're going to start by saying our first definition of trigonometry is this idea that if I have an angle and I take a triangle and I make it bigger or smaller, the ratios of sides is going to be the same. Trigonometry is the study of ratios of right triangles. Just to kind of piggyback quickly off of what you said, after spring break, we'll look at angles that are not inside of right triangles. We'll see where they are. We might even see that tonight. Hang tight. The sine ratio. The cosine ratio. And the tangent ratio. Are, bless you, abbreviated as doing two things. I'm going kind of quick. So for those students who have zero background or really a lot of cobwebs on your trig, I'm about to say what they are. I just have to tell you, it's like a definition. Like at some point, someone had to tell you, this is a phone. We don't call it a dog. It's called a phone. That's called a definition. There's nothing to explore there. Someone has to make a rule. So someone made a rule that said, these ratios are the same. They're proportional, as Mike noticed. So I'm going there. Now, the sine ratio, I'm about to tell you what it is. But first of all, I'm saying we always abbreviate it as SIN. You're going to say sin at some point. Math teachers think that's a sin. So try just to sound educated. Don't say sin, you say sine, even if it's abbreviated. When you see cos, don't say cos. Say cosine. And when you see this, what are you going to say? No, everyone says tan. I'm not joking. I don't get the friggin' rules. I hate this stuff sometimes. I really do. We don't say sin. You don't say cos. You say sine, cosine, and then teachers and YouTubers and people would say tan. Like that one is okay, apparently. All right. I don't know. We'll be a little more elegant. I'm going to fall guilty. I never say sin. Sine, cosine. I try to say tangent, but I probably will say tan. All right. That's a little humor. But seriously, don't say sin or cos. Sine, cosine, tangent, people do say. Secondly, we would say something like this. Hang on. What follows is an acute angle. So I'm just going to say angle, and I'll show you what that means in a minute. Angle. Angle. Here we go. Now I'm going to tell you what they are. Just like this is a phone and this is the color black. This is not exploratory. Someone said this is what sine is. It's the ratio of opposite to hypotenuse. It is a ratio. Trig is about ratios. Cosine is adjacent to hypotenuse. And tangent, what's up?
Are those being divided?
Yes, ratios. So a ratio is like boys to girls or hip hop to country, right? So you say, how many hip hop albums country? Like it's a ratio, it's a comparison. Yes, fractions. Tangent is opposite over adjacent. And that's a lot of words to write. But again, I'm assuming that we have no background, and I know that's not true. I know 60% of us do have a background, but I'm trying to find a balance between no exposure, exposure. We have 3 weeks to cover whatever. So those who know a little bit more, all good. But this is the must knows. This is the must knows. Furthermore, you heard of PEMDAS, right? Please excuse my dear Aunt Sally. It reminds us how to do order of operations. Well, if you've never met SOHCAHTOA, this is SOHCAHTOA. Everyone knows SOHCAHTOA, just like everyone knows PEMDAS after you take trig. SOHCAHTOA. It's a shortcut to remembering what the ratios are. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And as you go on spring break, you're going to say SOHCAHTOA to yourself. Yes, you are. You are. You have to say SOHCAHTOA and remember what they are. That's why I wanted to lay this out before spring break, so you can have the must knows, not at the end of the semester where we're rushing. Okay. We're going to apply this in just a second. Are we good? how well you've been paying attention. What do we label angles? I'm not flipping you off, but I thought I was for a second. I was like, geez. What do we label angles? Capital letters. Let's mix it up. What's a 3-letter word that's appropriate that I can write? Dog. Good one. D. You know what I don't like about dog? The O can be mixed up with the number 0. Dig. D-I-G. I dig this lesson. I feel like I'm in the dig it. Cool. What do we call sides? Lowercase letters. Okay. But I'm going to go somewhere else with this. I'm going to make up some numbers. Well, let's do this first. We already showed that if you had 3 and 4, the hypotenuse is 5. Next, the sine and then you put an angle. So I'm going to use a capital letter. For right now, we're going to use the acute angle. Well, how many acute angles are in this picture? So choose one of them. Is a ratio. What number value, again, I asked this about 25 minutes ago. I said, who's opposite G? You told me a segment, but this is new letters, and now we have a number. I want to know what number value is opposite G. 3. What's the hypotenuse? Done. You've just, if you had no trig, that's all it is. It looks scary as heck, because like what? Bro, it's just a ratio. It's a sine ratio. What's cosine of G? Means you go to this angle, you're like a stick figure. That's always hypotenuse. That's opposite. This is the adjacent. So, adjacent over hypotenuse, 4/5. Who's tangent G? What's the ratio tangent G equal to? 3/4. Your turn. Find the sine of D, the cosine of D, and the tangent of D. Acute angle D, new perspective. Hypotenuse never changes. Hypotenuse never changes. It's always opposite 90. The acute angle, there's 2 of them. There's only one 90-degree angle. That means there's only one hypotenuse. If you're at this acute angle, 4 is opposite you. 4/5 is called the sine of D in this diagram. 3/5 would be the cosine, and 4/3 becomes the tangent. And if you're already feeling something up here saying like, yes, take a trig course. It's so freaking cool. It's like mathematically cool. And it's applicable, but it's not part of our curriculum. So I'm not going to say it because I want your brain to kind of put some of the interesting this together. All right, we're going to do a new example in just a second. I just want to talk about a few other things. A super common variable, x, y. But those are used in algebra typically, in like equations. We use capital letters as variables for angles, but there's also one or two more. But the most famous other variable is that. So this is a variable. It's an unknown number, just like x and y. But we specifically use this variable to stand for an angle, almost always. Anyone know what this is called? It's from the Greek alphabet. If you watch, any sororities or fraternity type movies, alpha, mu, theta, gamma, beta, and it typically just represents an unknown angle. So sometimes we use capital letters, okay. Sometimes we use theta. Find the sine of theta. I'm going to do a new picture in a second. The cosine of theta and the tangent of theta. You can use a calculator. You're going to need to use a calculator. And I'm going to mix something up a little bit here. You got some work to do.
How do you know which one's the opposite, which one's the adjacent? I know you said it, but then as soon as I went to go dig one, I was like, oh, wait, do I need to like turn my paper over and look at a different way, or is it always going to be the same?
Here's how I've learned to sell it, because I used to struggle with that. It's a great question. So you have a question that many students have asked me. And in my career, I didn't have the best answer. I don't know if this is the best answer, but this is my answer now. Okay, I'm trying to get one last thing. So the question is, how do I know what's opposite and adjacent? We first identify the right angle. And that number is always your hypotenuse. That side, I should say, not that number. That side is always your hypotenuse, opposite it. I just used the word opposite it. What does it mean to be opposite it? It's like if I was a stick figure, I'll kind of draw it this way. One of my feet, and I'm at this angle, but I have to put my foot on each of the two sides. Then what I'm looking at is opposite at me. So opposite 90 is the hypotenuse. Cool. And I think this is going to answer your question. This is why I highlighted this over here. This tells you where to go. This tells you you're the stick figure. G. So we were here. And if I was a stick figure there, one of my feet has to be here. The other one has to be there. So what am I looking at? That's my opposite side.
Okay. And then obviously the last one would be the adjacent.
That's already hypotenuse. So by process of elimination, whoever's next to you is adjacent. But the reason I don't say that, because some students say, well, is that the adjacent? Because that's next to me. Yes, that is next to you, but it's already been claimed as hypotenuse. So my strategy is identify the hypotenuse right off the bat. Boom. Because then that gets a label. And if you're at this, what you're looking at is opposite at you. If you were over here, this would be opposite at you. Does that clarify it?
Yeah.
If someone has a better story, please share or... You do have some work to do. There's something I did not do. I'm leaving purposely open. So there's theta. My story says you have to put a foot on each side, and where you're looking at or the side your foot is not on, that is opposite from you. You have hypotenuse and you have adjacent.
Is the adjacent where the could be?
Where's the right angle?
No,
The point. No, yeah, I'm going to start from the beginning because jumping right here. That's the hypotenuse. Now, if I were a stick figure, 1 foot on each side, and this is telling me where to stand as a stick figure. What side is my foot not on is opposite me. Opposite me is 21. Opposite theta is 21. And therefore, by process of elimination, or what it means to be adjacent, I'm adjacent to you. He's not over there. I'm just close to. Well, as a stick figure, that's already been claimed as a partner. This is the side that's adjacent to me. Boom. But I have an issue. What is that number? Do I even need that number? Yeah, I do need that number because cosine says you need that number. Tangent says you need that number. How do I find the missing side in the right triangle? Pythagorean theorem. Super common question, definite test question. Definitely like final exam question. Right? It's a good question. It's not impossible, but it starts to build. It gets a little exciting. We need to find the missing side of a triangle. We also have to pay attention. The hypotenuse is C. The other values really don't matter. I guess I'll use blue for a change, so I'll call it B. A squared plus B squared equals C squared. We have to find that missing adjacent side using a calculator, which I will pull up because we're going to need it momentarily anyways for something else. Um, 29 squared is chilling on one side of the equation. I could hit enter, but I'm just going to say I'm not going to because I'm going to subtract the 21 squared. Now I'll hit enter. And then I'm going to take the square root, even though I see what the answer is, but I'm going to take the square root of my answer and find that that's 20. Pythagorean theorem, 100% working. It's going to work throughout trigonometry. You absolutely have to say to yourself, I need a technique. If my technique doesn't work, find a YouTube video. I can help you, right? But you need to be able to identify what's opposite, adjacent, hypotenuse. Then the trigonometry is actually very easy. It's a ratio. Actually, they're all ratios. So, ka, toa. We formally say the sine of theta is opposite over hypotenuse. That's your final answer. That's it. 21 over 29. We say the cosine, which we abbreviate as cosine of theta, is adjacent over hypotenuse. And lastly, the tangent of theta is your opposite over it's going so well. Your adjacent. I think this is a super helpful slide. So if you want to snap a picture of it with your phone, feel free to. The colors. If not, I definitely triple check that this is recording because there's been some issues, even though it's like, that's why I was like, I'm making sure this is recorded for sure. What? I checked it. I literally triple checked it. Make sure this is still charged. Okay. But if that made sense to you, cool. Here's a new question that applies the same thinking. So that's my spoiler. Because I want to give you a minute or two. I'm watching the clock. I want to give you a minute or two to just say, could I do this? I'll tell you that the, what will I tell you? I'll tell you that the cosine of theta is 24 over 25. And I'll ask you to find sine theta and tangent theta. All right, guys, new question. The cosine of theta is 24 25ths. Please tell me what the sine of theta and tangent of theta are. Who's got an entry point? Not an answer, an entry point to help out your classmates. Don't be an answer giver. Get them started, though.
We already know two sides.
Two sides of what?
The triangle.
A right triangle. I don't see a right triangle here. Maybe I should draw one. There's step one. Draw a picture. It's been a while since we've heard that problem-solving strategy. Draw a picture. Actually, I guess we did that with Farmer Tim a little bit, but that's all right. Draw a right triangle. That's almost how most trig problems work. Doesn't matter how you draw it, as long as you have a right angle. That's not a capital letter. It's an acute angle. If you're stressing about where this goes, let me relieve some stress. It don't matter. You just live with your choice. There, here, eeny, meeny, miny, mo. All right, I'll go up there. If you did something different, don't rechange your picture. Next, cosine. So, that ratio tells me adjacent must be 24 and hypotenuse must be 25. All right, I think I almost gave it away at this point. This is more than a giveaway. Find now the sine and tangent. I don't think I need a calculator for that, but for those who are going to watch this video later and you're just like freaked out on a test, take the square root there. You get 7. Okay. So I found that missing side. And now, what is the sine of theta? 7/25. And what is the tangent of theta? Opposite over adjacent. Yep, very good. Pythagorean theorem, a squared plus b squared equals c squared. Make sure the hypotenuse is c. Probably last time I'll say that. Sine, cosine, tangent have abbreviations and definitions. Must knows. Typical question. You have 2 sides. You find the third, write the ratios. Also a typical question. Given a ratio, find the rest. You draw a picture, find the missing side, bang it out. If you have a calculator, take it out. Even if you haven't already, we definitely need it right now. And I will tell you, the phone calculator really will end up driving you nuts. A Desmos calculator is better than a phone calculator. Like the default phone, telling you, will drive you nuts. On this model, the sine, cosine, and tangent are written right there. There's other stuff. We haven't even talked about that yet. But on the top, sine, cosine, and tangent. Here's a fake-ish application. Fake-ish. You want to know the height of something. That can be hard to determine. You want to know the height of a skyscraper or a tree. I don't know why, but you do. Maybe there's a good reason. You're cutting it down, or you want to think you can, I don't know. You want to know its height. Unless you have like something big enough to take you to the top of the skyscraper or the tree, it seems like something you can't do. However, one thing you could do on this planet is say, I'm going to go to the base of that tree. I'm going to take a measuring tape, and this is something I can do. I'm going to go make up a fake number, 50 feet. You can do that on Earth. And I'm actually saying this is how trig is technically applied. There's a little more, but we're getting going. And now I'm over here. And you can download this app. It's called an inclometer. You don't have to, but I'm saying you could. So now they're free. But even before then, we used to do this when I was in elementary school, not middle school, but I remember we took this protractor thing. That existed when I was in elementary school. Phones didn't. That's how old I am. And we tilted our protractor with this like hanging device, and it measured the angle, like even with a cheap tool. And it was obviously accurate as no good at all. It was terribly accurate, but it was something. And so we would measure to the top of the tree just by looking at it. Boom. Phones do it way better. When I teach high school, we do it. We go outside and I say, see that cell phone tower over there? I want to know its height. I know it's height because I looked it up online. But I want to see if you guys can do it. So they measure how far they are. They take out their phone, boom. And we get a angle measure. I'm going to say 23. By the way, angles aren't just whole numbers. They absolutely could be decimals. So I'll say it's about 23.7 according to my phone app. I claim we can find the height of the tree now with a calculator and two very human measurements. I'll call this X. I could call it A or B. I'll call it lowercase letter. Try not to call it a capital letter. Definitely don't call it theta. But it's a side length. I'm going to call it X because we're about to do an algebra equation with trig in it. Do I have an acute angle? Yeah. So I'm craving, and don't write this, just watch. I'm craving either sine, cosine, or tangent of 23.7. Now, the one I'm going to put there is depending on what the question is. Stick figure, what side is this? Opposite, adjacent, or hypotenuse? Improvement already. Is this adjacent or hypotenuse? Which ratio uses adjacent and opposite? Maybe not in that order. Tangent. If I lost you, so, but that's not, I don't care. This question has not, it's not asking me anything about the freaking hypotenuse. Not helpful. Not helpful. Tangent's going to be helpful. Tangent's going to be the ratio of opposite to adjacent. So nice and cleanly now. Tangent of 23.7 degrees is X on top of 50. The right-hand side is a ratio. It's X divided by 50. What undoes division? Multiplication. So if we multiply both sides by 50, we've solved for X. 50 tangent 23.7 is the answer. That's what we do in algebra, right? Solve for X. There. And then we turn to our calculator. 50 tangent 23.7. It turns out that was not a very big tree at all. But that's okay. Fake, that's what I get for just winging numbers. But it's not, that's one. Probably a good-sized Christmas tree. Yeah, medium. but it would be about 21.9 feet tall. Pretty neat. And that's called indirect measurement. It's literally what is done. When you're driving down the highway and you see people working, which isn't very hard to do in Rhode Island, like you literally can just close your eyes and probably open them and you'd be like, oh, there's someone working on the road here in Rhode Island because we have amazing roads. But all kidding aside, when they have those little tripods and they're measuring, they're doing, honestly, indirect measurements. They're doing different angle measures, maybe not finding heights, but that's one way they're doing it. They can use it to find distances, so they're using angles and not necessarily right triangles. And unfortunately, we don't get to it in this course, but they are finding like different lengths. There's something called a law of sines and cosines that you'd see in a trig course that applies to non-right triangles. Our focus is just here, but I'm taking an opportunity to say where this stuff does get applied.
Is it also used in
Land surveying, I mean, there's countless episodes where like things that trig uses. That's why I like teaching it, not just for its applications, but it is really used in so many things. And we'll see why once we get into something else shortly. Once we leave right triangles, it makes a lot of freaking sense. It's my favorite stuff. All right. Let's do kind of one more of these and then kind of start wrapping up before spring break this week or spring week. Whatever. Anyone traveling for spring break? I might go to Warwick. I mean, I'm in Warwick right now, but I might come back from Johnston. It's going to be like crazy like I do for... all right, so I want to do two more things. I want to do one more of these and then kind of wrap up something else. I'm going to strip out the word problem just to kind of cut to the chase of it. Find x. Okay. Students get confused. They like, can I use the Pythagorean theorem? First, come back. Do you have a right triangle? Yes. Second, do you have two sides and only one unknown side? If you can say yes to that from earlier tonight, you had two, and it doesn't matter which two, you can find a third. But if you don't have two, you only have one, that's unknown and that's unknown. Pythagorean theorem, you can stare at it till blue in the face, nothing's going to happen. Another application of trigonometry, it helps us solve right triangles when you only have one side, but you do need to have the acute angle. This is your stick figure. This is cool. This is not adjacent. Right? So find your adjacent. Got it. Sounds like you guys got it. Cool. Does sine use opposite and hypotenuse? Oh, cool. Sine of 25 is 7 over x. We solved for x in the previous tree example in one step. This one's going to take 2. But I just want to talk it out. I don't want to write it. I'm going to multiply by x. Gone. It's now chilling over here. Then what am I going to do? I'm going to divide by all of this. Treat this as a number that's going to come out of our calculator. But before I put that in a calculator, I'm just going to divide by all of it. And here's what I want to show. What really end up happening. This comes over here. That goes down there. It's like cross multiplying. They just switch spots. I'll show it. You can show it. But it just gets muddier as we get into more things. I'm multiplying by x. the x's cancel out. 7 would be chilling. But now x has a neighbor, so we need to divide by sine 25. So it's going to become 7 on top of sine 25. So let's just get there every time. Just write that. When your variable's on the bottom, bring it up top, bring that one back down there. That's the legal move. Quick. Go to our calculator. 7 on top of sine 25. And that would be about 16.6. Questions? What's up? I was waiting for someone. Was anyone else not getting these numbers? You already know? Does anyone know what's going on? If you had trig? I was waiting. Finally. Have you ever heard of radians? You have? Who else has heard of radians? Who's not heard of radians? Cool. We'll hear of radians after, except for right now, we're going to hear about it. It's another way to measure angles. I love it. So I'm not even going to I want to teach it right now. I'm not going till after spring break. It's one of my favorite. I have so many favorite lessons. This is another one. I just have this one in my pocket, ready to go. I love it.
So is radians,
It's a different way to measure angles. That's all I'm going to say.
but it's not a measurement. Is what I'm asking.
It is a measurement. It's a different way to measure angles. So we can say, and a little spoiler because I really it's. Don't do it. Well, we can say a circle has 360 degrees. But we can also say a circle has a different way to be measured. I'll leave it at that. I don't know if it's pretty obvious, but okay, one last. I can't even help myself. Oh my gosh. Why does a circle have 360? That's actually a very interesting question. And it turns out we can sit here all day and guess. But remember how I said someone had a defined sign? There's some stuff in math that is defined, and then there's other stuff that's consequences. It turns out the fact that a circle has 360 degrees has everything to do with our planet traveling around in 365.25 days in a year. But our ancient ancestors wanted to survive. So they studied the stars. They knew when to pick their crops. They knew when to bundle up. And they knew this stuff repeated every 365 days. But the mathematicians of the time said, bro, 365 divided by 2? Oh, man. And they probably wanted to split stuff in half. 365 divided by 4? Oh, man. 365 divided by 5? Okay, that worked. But 365 divided by 10 or 12, or if we wanted to think about breaking it up, because mathematicians think that way, they're weird, that number sucks. So they went and said 360. That's why. So it turns out, if we met aliens, they would be like, what? Like, what? Because they're probably going to come from a planet. Now, scientists have proved if there's living life on planets, there's a certain amount of distance where it's too close is too hot, too far is too cold. But if we're 365 and this alien planet might say, no, bro, a circle has 400 degrees. it doesn't make a difference. Because you know what? If an alien came here, they're not measuring degrees. Radians is universal. I'll save the rest of the story for when we come back. We're going to do alien math. That's why I teach this. It's literally alien math. No, that's what I call it. We're going to be aliens. And we're going to measure angles not on Earth. Can there be a spring break over already? Should we just stay? Okay, good idea. Until then,
I would never forget.
back to, and Sheila, if you are, here's what I was going to say, and it's going to tie into the last 10 minutes I have left. Eventually, I'm going to say, guys, do a sign check. What? I'm going to say, do a sign check on your calculator. Sine of 30 better be 1/2. If it is, your calculator is in degrees. And your calculator might give you 0.5. That's okay. It means you're in the right mode. But eventually, we'll switch to radians. Not right now. So if it's in degrees, leave it. You're good for your homework. But here's something called radians. And because we switch, depending on if we're on Earth or alien math, but I'll say, you forget you're about to take a quiz, and I will say, all right, do a sine 30 check, and you're not getting 1/2, you're in radian measure. You say, oh, let me switch over. Perfect segue. That was like planned. Why is sine 30 1/2? First answer, my calculator says so. Cool. Valid. But this is also historically, mathematically interesting. What do we call a triangle? I don't know why I'm doing that, but what do we call a triangle where all the sides are the same? Equilateral triangle. And if all the sides are the same, what is true about all the angles? What do all the angles add up to? If they're all the same, then each one is 60. Okay, let's sketch an equilateral triangle. That means all sides are the same. So that looks pretty equilateral. And all angles have to be 60. I guess that looks pretty good. Maybe not perfect, but I'll let it go. Does anyone see a line of symmetry? Meaning something we could fold this so it would fall on itself. Where?
From any point straight down.
I like that you said straight down. It is true from any point, but since you said straight down, let's go from right here straight down. There's a line of symmetry. Man, this is definitely not drawn a scale. But the theory is there. What's this angle? 90. Because we went straight down. And if I drew this perfectly, if we took a piece of paper and folded it, then everything would overlap. This is messing with my mind a tiny bit, but in theory, it's there. What's that angle then? This piece. 30. Someone give me a nice side length. We said an equilateral triangle is all sides are the same. So choose an easy number, just randomly, whatever you're thinking of. 9, okay. 9 it is. That means this side is 9. If this was drawn appropriately, all of this is 9. How much is that? 4.5. We're cavemen. We're cavewomen. We trust that there's 180 degrees in a triangle. We trust that there's a line of symmetry. We're cavemen. We're cavewomen. I don't know what a calculator is. What the hell's that? You future. But we do know the sine of 30. Here's a right angle. That's hypotenuse. Here's 30. This is opposite it. The sine of 30. I said choose a nice number. Doesn't matter what you choose. You told me 9. We figured out this is 4.5, which if you divide by 4.5, you get 1/2 every single time. It's not because your calculator says it. It could have been 2. That would have been a nice choice. And if that was 2, what would have this side been? 1. And then you say the sine of 30 is 1/2. Or you could have said 200. And this would have been 100, which still would have made a ratio, a sine ratio of 1/2. That's friggin' neat. The sine of 30 degrees is 1/2. Very human. Very human. No calculator needed. Now, the rest of those, I wish I had a story for everything. Turns out I have a story for this guy. I'm going to go with 2. You could use 9. I'm going to go with 2. What shape is this? I'm going to draw in this diagonal. No calculator needed. I now have a triangle. If these two sides are the same, what do we call a triangle that has two sides the same? Not equilateral, but it begins with I, ends with Solis. Guys are amazing. And if two sides are the same, these two angles are the same, and it's also just common sense that if this is folding, these have to be 45 degrees. What is the sine of 45? From this picture, actually I have a choice. It's not going to matter. But I do need the hypotenuse. And we're almost done for the week. How do you find the hypotenuse? 2 squared is how much? Plus 2 squared is 4 and 4 make. And then we would take its square root. Really quick algebra story. And a calculator would do this. There's nothing wrong with that answer. But it turns out it does simplify. Don't worry about it. We'll see another day. Trust the calculator here. That's a perfect square. So it's 2 root 2. We leave it like that. The hypotenuse is 2 root 2. So the sine of 45 is, here's an acute angle. This is opposite it. By the way, if you said, well, why didn't you go to that one? You would have still got the same thing. You would have got 2 on top of your hypotenuse value, 2 root 2, which is 1 over root 2 when you cross out your 2's. And this is something we need to do. And I end here. It's called rationalizing the denominator. Very scary phrase for something that is actually very simple and it looks medium. It sounds scary. It's very easy. And on paper, it looks in between scary and easy. We're just going to multiply top and bottom by the square root. This right here is called rationalizing. You take the bottom denominator and you multiply top and bottom by it. And we get we get root 2 on top of a square root times itself cancels out. Sine of 45 is square root of 2 over 2. Why? I didn't need a calculator, but my calculator would tell me that answer as well. I said I wanted to do trig for a variety of reasons. This is my last talking point of the day. It is absolutely worth memorizing. 1, a squared plus b squared equals c squared. If you have a hole in your ship or not, memorize this over break. Take some time. Make an index card. These are your absolute must-knows. 2, so, ka, toa. This third one is that the sine of 30 degrees is 1/2. The sine of 45 degrees is root 2 over 2. And I'm out of time, but we could go back to that equilateral triangle. And we will when we return. This is a perfect welcome back. How was everyone's spring break? Let's go. But it turns out that this is root 3 over 2. Furthermore, the cosine of those angles. Why did I write tan? Oh, I did. Okay, I'm doing this right. My bad. About 40 minutes ago, I was like, oh, if you notice something, your brain's turning. And if you didn't notice it, I'm going to tell you later, but I'm going to lay out some facts. Cosine of 30 is root 3 over 2. Cosine of 45 is root 2 over 2. And cosine of 60 is 1/2. Remember, 30 and 60 would be in the same right triangle, so there's something to review when we come back. But I'm laying out facts that, even if you're not sure why they're true, they're 100% true, and if you can memorize them, you're really good. Last but not least, tangent of 30, root 3 over 3. Tangent of 45 is 1, and tangent of 60 is root 3. I have a trick to memorizing them, and I'm letting you go. It's as easy as 1, 2, 3. 30, 60, 90. Sine 1, 2, 3. Takes a little practice. There it is. 30, 45, 60. Said something I didn't mean to say. 30 is smaller than 45, is smaller than 60. 1, 2, 3. Guess what? They all have a square root on top. No, they don't. You're right. But it still would be okay. So, square root of 1, square root of 2, square root of 3. What do they all have in the bottom? 2. And the cosine just goes the other way. Tangent. Okay, I don't have a fun story, but I do have a way of remembering this. The 30 and the 60 both have a root 3. Which number is bigger, 30 or 60? So to make something smaller, you would divide. So they both have a root 3. The smaller one has a division of 3. That's my study tool. Have a great spring break. We'll get back to the test. There is a homework assignment, but maybe it's a good time to take a break, but not too much. You have some study facts. See you in 10-ish, 12-ish days. See you guys. Have a great break.